Okay, so now we have another example. In this case, we want to find a power series representation for this one. So again, in this case, you're going to want to, again, recognize that I can rewrite this as 1 over 1 minus x times 1 minus x, which of course can be written as 1 over 1 minus x times 1 over 1 minus x, and of course both of those are represented by the same series, which is f of x is equal to 1 over 1 minus x, which equals the series from n equals 0 to infinity of x to the nth power. So now what we're going to do, oh, and by the way, the interval of convergence is negative 1 to 1. So now what we're going to do is we're going to use the theorem to multiply these together, right? So this is good. We're just going to multiply n equals 0 to infinity of x to the n by itself, right? So we're going to just square it, okay? So what does that mean? Well, we're going to take and multiply it by itself, which means we're going to have something like this. We're going to have 1 plus x squared plus x cubed all the way down times one plus x squared plus x cubed plus all the way down, right? Okay, so when we multiply these, like multiplying polynomials, we do use the distributive property. So what are we going to get? We're going to get something that looks like this. It's going to be 1 plus x squared plus x cubed plus that. And then we're going to get the same thing, but we're going to get x, right? Because now we're going to multiply everything by x. So now it's going to look like this. It's going to be x plus x squared plus x cubed plus x to the fourth plus so on. And then plus, and now we're going to get something that starts at x squared plus x cubed plus x to the fourth plus x to the sixth. Okay? Oh. Plus, and so on, plus, and then it's going to keep indexing up. So x to the third, plus x to the fourth, plus x to the fifth. Hold on. Oh, I'm sorry. I knew something was wrong. This is to the fifth. And this is x to the sixth. And then it keeps going on like that. Okay, so now let's do the same thing we did before and simplify this and see if we can see what we get. So again, here we got 1x, or excuse me, I'm sorry, 1, 1. So this is going to equal 1. And then how many x's do we have? We got 2 x's, right? And then x squared, how many x squares do we have? We've got 1, 2, 3. Okay. And then the next one we got x to the third. And how many of those do we have? 1, 2, 3, 4. Okay, and then x to the fourth, how many of those are we going to have? Well, we're going to have 1, 2, 3, 4, 5. And it's going to keep going like this. So what do we end up getting? We get 1 plus 2x plus 3x squared plus 4x to the third plus 5x to the fourth plus da da da. So now, what's e sub n? Now in this case, we can come up with e sub n as a coefficient here, because it looks like this is just going to be n plus 1. Right? Because if n is 0, we get 1. If n is 1, we get 2. And so on. So we can actually write this as e sub n times x to the n, right? Which is equal to, well, n equals 0 to infinity, right? But by the theorem, this thing has to equal this pattern, or this form, right? So what's e sub n in this case? E sub n is n plus 1. So our final series is going to be the series for the summation from n equals 0 to infinity of what? It's going to be n plus 1 x to the n. And so that is our final answer, and we know that this has a radius of convergence of -1 to 1. And we're done. Have a great day.